Hello guys, welcome back. So in this video we are going to understand today Leetcode problem, that is 334 we have in this series, right? So let's continue understand this problem statement, right? So what the question is saying, that we have to find the maximum Manhattan distance after k changes, right? What is the Manhattan distance? As you know, in the childhood, right, Manhattan distance is between two cells. We have given x1 and y1, two coordinates we have given. So in that case we have to find the absolute value of x1 minus x2 and the absolute value of y1 minus y2, right? We have to find, and then we have to do sum, and we have to return that. That is called Manhattan distance. So let's suppose if in a coordinate system, right, if we have 2 points we have given at this and this, right? So let's suppose this is a and this is b. So this point is something we have 3 and 4, another coordinates we have and 5 and 6, let's suppose, right? So if you want to find the Manhattan distance, what we need to do, right, we used to do in the childhood if you are preparing for a JEE. So that time if you do the sum of these absolute values, how we are going to find it, right? 6 minus 4 we are doing, right? So absolute value of 5 minus 3 is 2. If we'll do 6 minus 2 is 2, right? So it will become what? 4. So 4 was the answer of the Manhattan distance. But we have given couple of things here just that you need to understand. Okay, give me some second. Okay, let's suppose what the question is saying here. The question is saying that we have given a string s, right, as you can see in the example, right? So what string is giving? We have given n, w, s and e. So as you know, there are 4 directions, right? North, south, east and west, right? So these 4 directions we have given, right? So it is saying that the string that will be given, right, in the string that is given n, w, s and e are the 4 directions we have given in a character. N, s, w, e, we have given all these 4 directions we have given, right? So at each character, that is called 0, right, it is index 0, 1, 2 and 3. So, and there can be more characters will be there, right? So at each index, that is called our directions we have given as a character. If the character we have given at a certain index, it means what? We have to move in that directions, right, by 1 unit, as you know, right? Initially, as you know, in the grid, you know this grid, right? So initially this position is called origin, and its coordinates is 0, 0, right? And from there you have to move. So initially you are at origin 0, 0, and you can change at most k characters to any of the 4 directions, right? And how? By if you have given the strings, right? Let's suppose we have given here and you are at here itself, so you have to come this direction, means you have to come -1 and 0. If it is given let's suppose south, right, it means you will go here, means 1, 0. This is what? 1, 0. Sorry, 0, 1, 0, 1, right? We have to move, correct? I hope you understand the problem. And you have to find the Manhattan distance, right? Means each time when you will move from the current position to the north, you will find the distance d1. Then you will move to here, you will find the distance d2. Like that you have to find, and which one is the max is coming, that you have to return as an answer. d1, d2, d3, so many distance will be there, 4, 5, 6, 7, 8, 9, 10, whatever the answer is coming, that you have to return the max one. I hope you understand, right? Now it's time to understand the code. So what code is saying that, right? Before understanding the code, let's talk about what we call, give me a second. Okay, so let's understand about the intuition, right? So as we know, for any given string, we can calculate the Manhattan distance using a very easy formula, right? What is the easy formula here? Let's suppose if we have formula something, what is the Manhattan distance? This distance I'm talking about, right? Means let's suppose we have sum n minus sum s, right? So we can take the absolute value and then we'll do sum east minus sum west, we can do. So this can be a formula, right, where we can calculate the Manhattan distance, right? Manhattan distance, we can say Manhattan distance, not Manhattan distance, I'm saying wrong. So Manhattan distance you can say, or forgive me if I'm giving the wrong name. Okay, so you can write these two in the absolute, math dot absolute, right? So what is these things? What is these things we have given, right? So we have given sum n, sum s, sum E, sum W, right? Means sum at N, sum at W, sum at E, like that we have given at these directions, right? It means these represents a number of occurrence at word north, south, east and west. So the string that we have given S can be many things, right? Many will be there. It can be occur many times, right? It cannot be only 4 directions in there. It can be many directions we have given, right? Because the grid can move to any direction in multiple times, right? Infinite times you can move, right? So the grid is infinite, it can move any times. Understood, right? Means we have to say these some N, some S, these are the number of occurrence of the directions in the string, right? Understand? Then just think that when we try to modify the letters in the string, there are 3 possible cases. What are the possible cases are there, right? If you want to modify, if you want to try to modify the letters in the given string, right, this is string, then what are the possible cases will be there? Let's suppose if we'll modify the letters that appears less frequent but not 0 in either the horizontal or vertical directions, right? Either horizontal or vertical directions, anyone, right? So so the Mahendram distance can increase, right? That increases the Mahendram directions. Either you are moving into horizontal or vertical, right? But it is coming less frequently, it comes, right? But it increases the distance. How much? It will increase either 2 points, you can say, right? By 2. That is one conditions, right? Another condition thing, if the letter that appears more frequently, if it is coming less frequency but it increases by 2, another is coming is more frequency, more, less and more, right? But it also increases by 2, right? Means if we want to modify the letters that appears more frequently in either direction, that decreases the Mahendram distance by 2. So if it is coming less, means it will increase, but if it is coming more, it is decreasing. Understand? It will modify the letters, that appears less frequent, right? So in either horizontal or vertical, right, it increases the Mahendram distance by what? 2. Means it increases the distance by 2. But if we are modifying that, that is less, you can say that letters appears more frequent, right? Frequency is more in either direction, either going horizontal or vertical, but it decreases the what? Distance by 2, minus 2. Then third condition will be possible? No, nothing, no modification are made. We cannot modify any directions in this, right? So if no modification are made, Mahendram distance remains unchanged, that is 0, right? So these are the possibilities that can be possible, right, when we modify the letters in the string, right? If we'll modify. So if you see, it is easy to see that only the first letter that causes an increase in the distances, right? The first letter itself, right? Because it is easy to see only the first case causes what? That increases the distance, right? Only the first case. Understand? So therefore we will divide the modification process into 2 steps. The very first step is what? Modify the letter with fewer occurrence in the vertical directions, right? In the vertical directions, in these directions, right? If the number of such letter exceed the given k, right? We have given k is there, right? If the number of such letter exceed k, then we'll modify only k of them. Only one letter will modify, right? We have given N, W, S and E and k equal to 1. It means only one letter will modify, right? And we will set the remaining modification count to 0, equal to 0. Modification count is t, then we will say set to 0 for the remaining. If the number of such letters is less than or equal to k, let's suppose the number of letter is less than equal to k, less than equal to k, then we'll modify all of them and we'll set the remaining modification count to 0. Let's suppose we have given only n and w, on k we have given is 3. It means what? How many letters are there? Just think, only 2, right? So if the number of such letter is less than k, it means what we know? Then we'll modify the letters, all the letters, right? And remaining will say set count to what? T. Understand? Then step 2, understand. This is your very first step, right? Where what we will do. In the step 2, we'll modify the letters with a fewer occurrence in the horizontal direction. If the number of such letters exceed, right? Let's suppose k is coming 1, but these letters are more, right? It's exceeding. Then only modify t of them, right? Only one will modify, or the count that we have given, that will modify, and modify all of them, right? Since the question asks us to modify the give the maximum Mahantem distance, right? The question is saying that it means the Mahantem distance from the origin at any moment during the execution of all the movement operation in order happening, right? So these steps must be carried out during a traversal of the string, and we must track and will return the maximum value that encounters, right? Let's understand the code here. So first of all, give me 1 minute. One second. What happened? Okay, leave it. Some problem is coming. Okay, just think that if we have given s and k, right? So first of all, we'll define the max distance, right? So first of all, what we need to do, we will define the max distance and we'll return this max distance once it is calculated, right? As you can see, we will return in this function, right? Then what we need to do, we'll define all these 4 directions, right? And we'll initialize 0, because these 4 directions is the count, right? How many count is coming in the given string. For each string that we have, for each characters that we have given in the string, right, we will traverse from 0 to the last character, right, in the string s. Each string we will check and will increase the respective count. Then we'll call times 1, we will say what is the minimum distance, right? Between north and south, between north and south, what is the minimum modification we have, right? What is the modification times for n and s? We'll get the times. Then similarly we'll calculate times 2, and that is for modification time for north and south, right? So k minus remaining times will happen, right? Because previously there was 2 steps were there, right? Step 1 and step 2. When we divide the modification process into 2 steps, right? The first step was when the first step was we modify the letters with a fewer occurrence in the vertical directions, right? This was the vertical directions, right? So in the first step, like we can say, we will modify the letters with a fewer occurrence in the horizontal direction. If the number of such letter exceeds t, then we'll modify t of them, otherwise modify all of them, right? And in this modification for n and s, right, north and south, right? I think east and west we can say. I write in without in the east east and west, right? Means so first of all, for the north and south, right, what we need to do means we have divided the process into two steps. The first step was to modify the letters with a fewer occurrence in the vertical direction. If the number of such letter exceeds k, then we'll modify k of them, and that is why we can take what the minimum. Which one is minimum? That will directly come to times. Let's suppose from north and south, it is the minimum is 5, right? But k is 2, so we'll take t equal to 2, right? Similarly, means how many modification required? So only 2 is required. From times 2, we'll take minimum between east and west and k minus times 1. So how many remaining is there, right? So remaining is, let's suppose k was there and we have removed times, right? Let's suppose the north and south is there. So let's say 2 and 3 is there, right? 2 and 3. But in the k we have only 1. How many was there? 1 is there, right? Let's suppose it is 2 and 3. And minimum was 1, so times will get 1, right? So this time will, let's suppose, give me 1 second. Okay, so sorry, it's taking time. So let's suppose we'll take two things, right? What are the things are there? We have north, we have south, we have given, right? So let's suppose it is given 2 and 3 is there, right? And k is, how many is there? 5, right? Just for example, there is multiple cases can be possible, right? So first step, let's suppose in the case 1, we have north, we have 2 times is coming, south is coming, 3 times is coming, and given k is 5, right? It means times is become how many? 2 will become, right? So k we have 5, right? But 3 more we need, right? 3 we more need, right, for the modifications, right? So in the next time, when the east and west will happen, right? Let's suppose east is 2 and west is 2 also, right? And this time k is also given what? 5 we have given, right? So 5 minus how many we have taken? 2 we have already taken for the times 1, right? So we'll do minus, so remaining is 3. Understand? Means we will take this time 2 to 3. Which one is minimum? That we will take, right? So like that we will find it and we'll calculate it, right? And we'll find all the modification for north and south and east and west. Now you have times 1 and times 2. Once you have times 1 and times 2, you will do what? The max distance, right? You will use the max between the count of north and south and count of east and west, right? And you will return the answer. How are you going to find the count? Let's see. So for the count, what you need to do, just you will write what? Direction 1, direction 2 and the times, right? So math.absolute, direction 1 means direction 2 plus times into 2, right? And you will get the count and you will finally return the answer. Okay. Anyways, thank you for watching this video. If you still have doubt, please ping in the comment box. And you know, we are traversing all the strings characters. We'll go for O of n times and there is no space. So we'll say O of 1 is the constant time. Thank you for watching this video. I'll see you in the next one.